Here are the notes for section 9.2, L'Hopital's rule. So L'Hopital's rule is used to find limits of an indeterminate form. So what that means, so there's a couple indeterminate forms, the first of which is 0 over 0. So the functions f of x and g of x are both 0 at x equals a, then the limit as x approaches a of f of x over g of x cannot be found by substituting, because then you get 0 divided by 0, which we can't evaluate. The substitution produces 0 over 0, meaning this expression known as an indeterminate form. So what L'Hopital's rule says, suppose that f of a equals g of a equals 0, and the f prime of a and g prime of a both exist, and that the g prime of a is not 0. Then the limit as x approaches a of f of x over g of x is the same thing as f prime of a divided by g prime of a. So we take the derivative at the top and bottom and then plug our a value in. So example 1 here, estimate the limit graphically, and then use L'Hopital's rule to find the limit. So graphically, we need to look at our calculator. So let's see here, graph. So we have the square root of 1 plus x minus 1 over x. So you can tell this is going to be indeterminate because if I plug 0 in, I get root 1 minus 1, which is 0. So 1 minus 1 divided by 0, so it doesn't work. So we draw. So let's zoom this in a little bit. Actually, we'll reset our view window. So it looks like, if you look at the graph, the limit's about 0.5, 1/2. So when x approaches 0, the y value is 1/2. So let's actually work L'Hopital's out. So I'm going to rewrite this numerator so it's a little bit easier to take the derivative. So that's my expression. So what L'Hopital says, if I take the derivative at the top, so let's see here, this becomes 1/2, 1 plus x to the negative half, so the minus 1 goes away, all over 1. So you do, now be careful, it's not a quotient rule. It's derivative at the top, derivative at the bottom, like that's it. You don't work them separately. So now I can try plugging my 0 in. So this becomes 1/2, 1 plus 0 to the negative half, all over 1. So 1/2, 1 to the negative half over 1. Well, 1 to the negative half is 1 divided by 1. So this all just comes out to be 1/2, which is what we got from the graph anyway. So just another form. You can actually keep taking derivatives if you need to. L'Hopital's rule can be chained one off another. So for example 2 here, evaluate this guy. So notice now we have higher powers. So we'll rewrite this 1 plus x to the half minus 1 minus x over 2 all over x squared. So now if I do the derivative, I get 1/2, 1 plus x to the negative half. So that 1 goes away. X over 2 is the same thing as half x. It just becomes minus half. Derivative at the bottom is 2x. So limit x approaches 0. So now if I plug 0 in, I get 1/2 minus 1/2 on top over 0. So I get 0 over 0 again. So I have to do L'Hopital again, take the derivative a second time. So now I get negative 1/4, 1 plus x to the negative 3/2. Then that goes away, and the bottom is now just 2. So now, let's try this. So this becomes negative 1/4, 1 to the negative 3/2, all over 2. So that's negative 1/2 over 2, which is negative 1/4. Nope. That should be a 4, which means that's a 4, which means that is an 8, negative 1/8. Okay, evaluate the final limits using L'Hopital's rule. So I can't plug 0 in because sine of 0 divided by 0. So if I just try it right away, I get 0 over 0. So L'Hopital's rule, take the derivative at the top, derivative of sine is cosine, derivative at the bottom is 2x. So this becomes the cosine of 0 divided by 2 times 0. Well, the cosine of 0 is 1. So this would come out to be sine of x over x squared, infinity, because number divided by 0 is infinity. Okay. So because I need my directions. So, oops, from the right gives me that. So if you notice here, it's going to be a similar thing. Sine of 0 divided by 0 squared, 0 is 0. So cosine of x over 2x. But since we're approaching 0 from the left, that means these are going to be negative. So we get negative 1 over 0, which is negative infinity. Okay, there's also a couple more indeterminate forms. Infinity divided by infinity, infinity times 0, or infinity minus infinity. So identify the indeterminate form and evaluate using L'Hopital's rule. So this would become the secant of pi over 2, 1 plus the tangent of pi over 2. So in this case, this becomes infinity over infinity. So we need to differentiate the numerator and the denominator. So take the derivative. So derive the secant. Is going to be secant x, tangent x. Derivative of 1 plus tangent is just the secant squared because the 1 goes away. So this cancels with that. So I have tangent over secant, which is the same thing. So tangent is sine over sine over cosine. Secant is, so dividing by secant is the same as multiplying by cosine, so those cancel. So this is just a limit as x approaches pi over 2 of the sine of x. So the sine of pi over 2 is equal to 1. So there's your limit. Okay, so example 5, identify the indeterminate form and evaluate this one. So we get ln x over 2 root x. So this become the natural log of infinity over 2 times the square root of infinity, which is still infinity over infinity. So derivative of the top, so limit x approaches infinity, is 1 over x. On the bottom, derivative of 2 root x was going to be x to the negative half. So to simplify, there's no equal sign there. So this becomes 1 over x over 1 over root x. So this is the limit as x approaches infinity of 1 over x times root x over 1. So root x over x simplifies. Keep losing my limits. Just simplifies to 1 over root x. So this becomes 1 over root infinity, which is 1 over infinity, which is 0. All right, so the limit is x sine 1 over x. So let's see, our indeterminate form would be infinity times sine over 1 over infinity. So this would be infinity times 0. So there's our indeterminate form. So what we're going to do in this case is that we're going to switch it and set, no, we're actually going to reciprocal everything, for lack of a better word. So we're going to set h equal to 1 over x. So this becomes the limit as h approaches 0 of 1 over h sine h. So h is just the reciprocal of x. So that's why this becomes 0, because the reciprocal of infinity is 0. The reason I do that is I can now write it sine of h over h, which I can do L'Hopital on. So this is still, so this would become, oh, no, that's a 0. So this would be 0 over 0, so I would need to L'Hopital it. So the limit as h approaches 0 of the cosine of h for 1 would would become the cosine of 0 over 1, which is just 1. So there's your answer. Okay. So this work, comes out to be the same for similar rules. So you do the same substitution. Limit. Oh, so sorry, this would be, there's little plus signs here. So this is going to be limit h approaches 0 from the left of 1 over h sine h. So limit h approaches 0 from the left, sine h over h, which is 0 over 0. So L'Hopital, cosine h over 1, 1 over 1, 1. All right, so this next one here, 7, 1 over ln x minus 1 over 1 minus x. So this one has the form, if I plug it in, I get 1 over 0 minus 1 over 0, which is the same thing as infinity minus infinity. So in order to fix this, I need to common denominator these guys and get it to a single fraction. So this first fraction needs to be multiplied by x minus 1 on top and bottom. And the second one needs to get multiplied by ln x, whoops, on top and bottom. So I can get a common denominator. Oops, x approaches 1. So this becomes x minus 1. This becomes minus ln x all over x minus 1 ln x. Okie dokie. So now if I try to do this, the limit as x approaches 1, I get 1 minus 0, so this top is 0. The bottom is also 0, so I add a L'Hopital. So derivative of this is going to be limit as x approaches 1. Derivative of x is 1, that goes away. Derivative of the natural log is 1 over x. All over on the bottom, let's see here. X minus 1 times natural, so derivative of the first times the second is going to be ln x plus the first times derivative of the second, x minus 1 times 1 over x. So that's product rule on the bottom there. So now if I plug 1 in, I still get 0 over 0. But before we do anything, we're going to clean this guy up a little bit. This is the same thing as, we'll come up here. The limit as x approaches 1 of 1 minus 1 over x all over the natural log of x plus 1 minus 1 over x. So essentially I just took this 1 over x and distributed it. So x times 1 over x is 1, negative 1 times 1 over x gives me that. Okay, so now I need to L'Hopital again. So derivative of that is going to be 1 over x squared. Derivative down here is 1 over x plus 1 over x squared. So now if I plug 1 in, I get 1 over 1 over 1 over 1 plus 1 over 1, which is 1 over 2. So the whole thing comes out to be 1/2. Okay, so a couple more indeterminate forms, 1 to the infinite, 0 to the 0th, or infinity to the 0th. So what this is saying is that you take the natural, if the limit of the natural log of your function is L, and the limit of your actual function is e to the Lth power. So what's going to happen here is that, excuse me, I'm going to convert, excuse me again, I'm going to take the natural log. So natural log of 1 plus 1 over x to the x. So because I have a natural log, this exponent can come out front. So x ln 1 plus 1 over x. So now what I'm going to do is I'm going to take this guy and make it a fraction. So he's going to move underneath as the reciprocal. So this is what I'm working with. limit as x goes to infinity. Now if I try to do that though, I get the natural log of 1, which is 0, divided by 1 over infinity, which is also 0, so I need to L'Hopital this. So the Masculine derivative of the top is, natural log is 1 over 1 plus whatever's inside the log times the derivative of what's inside the log all over the derivative of the bottom. So we get this. Now if you notice, these guys can cancel, so I just have to worry about this. So that becomes 1 over 1 plus, which is 1. Now, since I took a natural log way back here at the beginning, the limit as x approaches infinity of the original equation is equal to e to whatever the limit I found was. So e to the first, or just e. All right, determine whether the limit of x to the x exists, and find its value if it does. Okay, well, we're going to take the natural log, which becomes x ln x, which becomes ln x over 1 over x, limit as x approaches 0. So if we try to do this, we get infinity over infinity, essentially. So we should get negative infinity over infinity, so we got a L'Hopital. So 1 over x over negative 1 over x squared. So we have this, which all just simplifies to the limit as x approaches 0 of negative x, which is 0. But since I took a natural log way back at the beginning, the limit as x approaches 0 of x to the x is e to that number, or just 1. Now the trick here was that this one flips over and multiplies, so I have 1 over x times negative x squared over 1, so the x's can cancel, leaving me just negative x. So what I did was this. So that's negative x squared over x. That cancels that. There's your negative x. All right. S approaches infinity of x to the 1 over x. Okay, so natural log. So ln of x to the 1 over x. So 1 over x comes out front. So this is actually already set up. So this is ln x over x. X approaches infinity. This is an indeterminate form. It is infinity over infinity. So I have to L'Hopital. So derivative of the top is 1 over x. Derivative of the bottom is 1. So I have this. So this becomes 1 over infinity over 1, which is 0 over 1, which is just 0. But that's not the answer. Limit, since I took a natural log way back at the beginning, I get this. I have to remember to put it as the exponent on an e. And that is the end of the section.